Hello everyone, our team's name is the Audio Samplers, and we have created the Audio Sampler 1.0, which is a audio sampler that can input up to 9 audio samples. So let's say we click on Audio Sample 1, and then we can click on any music file that we have in our computer. So let's say this one. If we press on play, then we can hear it, and then if we press on stop, then we can stop it. Let's do another one. So if we press on sample 2, then let's do a different one. Let's do this one, for example. And then we can press on play. Then if we press on stop, then it stops. Okay, and then let's say we want to record our own voice or anything. We can press on record. And then it is recording as indicated by the red light. And then if we want to stop it, then we can stop it. And then let's say we want to save it into sample 2. So let's go to sample 2. And then if we save it, and then we play sample 2 again, press on record. And then it is recording as indicated by the red. And then it will play my recording. And then obviously if I stop it, it stops. Okay, so let's say if I want to filter sample 1. So let's play sample 1 again. And then let's say I want to filter it. So I have 3 types of filters. So high pass, low pass, and band stop. So high pass is where you want the higher frequencies to be more prominent and the lower ones to not. Low pass is where you want the lower frequencies to be more prominent and the high ones to not. And band stop is where you want the like kind of in the middle, where you want the lower and the higher frequencies to not be more prominent. So if we press high pass, then let's do a value about like right here. And then let's do an order of 2. The order is basically the effect of the filter that you want on your music. So if you have a higher filter like 2, then it's a greater effect. And then if you have a 1, then the effect of the filter is not so high. Okay, so then if you press save, and then you press on sample 1, and then you can obviously see that the signal waveform has dramatically changed from before. Okay, so let's say we want to save our recording this time. So our recording is in sample 2. So if we press on sample 2 and we name it whatever we want, so let's say Eli, and then it says here add.mp3, .wave, or .anf to end of name. So if we put .wave and then save on computer, then it saves it to our current photo. So we press OK, and then let's go to our current photo, and it's right there. And then if we play it, on record, and then it is recording as indicated, then it's successfully saved it. Okay, so let's go to our code. So let's first go over the sample button. So if we press the sample button and the text says sample 1, then it's basically going to get the input audio that you inputted, and it's going to get the sample data and the sample rate, and it's going to store it into app.data player 1. And then if the text button says play, then it's going to play it, and then otherwise it's going to stop it. Okay, and then we did that for the rest of the other samples. So sample 2, sample 3, and so on. Okay, and then if we go to the record button, basically it uses the audio recorder function to record the audio from your microphone or computer or whatever, and stores it into the rec property, and then it records the recording. Okay, and then if we press stop, then it stops the recording. Okay, and then if we want to save the recording audio to any sample, then we basically get the data from the recording, and we store it into this new array called Y1, and it's going to basically replace the audio from the sample data 1 button and replace it with this new Y1 array. Okay, and then let's go to our filtering. So basically this is going to check if this is sample 1, and if it is, it's going to check again whether this is high pass, low pass, or band stop. If it's high pass, for example, it's going to create a buttle filter, as you can see right here, and it's going to create it in terms of its of the auto value that you input and also the cutoff frequency that you inputted. And basically it's going to filter the data, and then it's going to replace the sample data that was originally in the button with the new filter data, and then it's going to do that for the rest of them. And then so sample 2, same thing, sample 3, same thing, etc. Okay, and then if we press on save on computer, it's basically going to write a new file in your current photo named whatever you put into the name edit field, and then it's going to get the sample data from the first button and also the sample rate from the first button. Okay, and then other than that, then I would just hand it over to my partners.
Hello, my name is Calvin, and I was in charge of manipulating and editing the sound files. So currently we have this sound file, and then now we're going to manipulate it. So the first thing we have is playback direction. So as you would expect, this changes the direction it plays. Instead of going forward, it will now play backwards. And if you look at the sound wave, it flips too, and we can change that back to forward. And now it plays like normally. Next thing we'll do is playback speed, so you can slow it down or speed it up. So in this case, I'll show you at 2 times speed. And as you can see, it plays much more faster. And another thing you can do is delay time, which is echo. So I'll put an echo of 1 second, and then you will see that it plays, overlaps itself after 1 second. So now you have 2 of them playing. So we're going to put that back to 0, and then now we're going to change it to volume. So if you want to make it quieter, you can put it at whatever volume you want. So I put it at 20 in this case. And now it's much more quieter. And if you put it at 0, you shouldn't be able to hear anything. As you can see, there's nothing. And then you can turn it back to the original volume. And now you're back with the original audio file. And the next thing that we can do is chopping. So this will cut off portions from the start or the end of the file. So in this case, I'll cut off 5 seconds from the top, the first start and end. And so we have around a 40-second file here. And after we click save, you'll see that drop to around 30 seconds. As you can see, it started immediately 5 seconds in within the sound wave. And so that's how the soundboard works. Now let's get to the coding portion of it. So on the code, we first start with a switch case that takes the data from the sample of the button that you clicked, and then it puts it into a variable that we use for manipulating. So for the playback direction, we flip the sample data, which is the sample array. For volume, we multiply the sample array by a certain value to increase it or to decrease it, setting the normal value of itself as 50. And to delay it, we take the file, duplicate it, and then shift that file array for the amount of time the user specifies, and then add them back together. For the playback speed, we use a function called stretch audio, and that will stretch the audio to be faster or to be slower. And then after they click save, we return those changes back to the original sound file for it to be able to graph and play with the new audio. Another feature that I wanted to point out is that if you try to edit and manipulate a file that's not yet uploaded and you click save, it will have an error message that telling you that there is no file uploaded into that.
I'm Jack Hervey, and I will be displaying the synthesizer and tone generator of the Ultimate Sampler. In this box here, we can see that we have a synthesizer where you can adjust the amplitude, sample rate, frequency, and time duration of the sample, as well as generating it using 3 different wave functions, including sine, square, and sawtooth. We're also able to save the sample to the soundboard using this drop-down menu up here and the save button here. So if we want to go ahead and create a sample, we can input an amplitude, a sample rate, a frequency, and a time duration. And then we go ahead and hit generate here. And we can see that the sample is plotted on the wave, on the plot here. Unfortunately, it's very hard to tell at a high frequency rate due to limited space that it is actually a sine wave. But if we drop the frequency rate down, we can see that is indeed a sine wave. Same thing when we go to square wave, we get the same thing. And then when we go to sawtooth, we also get the same thing. Now if we go back to sine and frequency of 500, and we save this sample to the soundboard, we see that the button over here in the sample 1 position changes to play. So when we hit this button, it now plots it on the main axis here, as well as playing the sound. Now we have a few error messages coded into the soundboard here, the tone generator here. When we input an amplitude of 0, we see that we get an error message saying the amplitude cannot be 0, otherwise a wave function will not be plotted. Same goes for sample rate. We have a range that is accepted, and if the sample rate is too high or too low, we will get this error message saying that the sample rate must be in between 1,000 and 200,000. Same thing with the frequency. If we put in a frequency of 0, we get a message saying that the frequency cannot be 0. Same reason as the amplitude, a wave will not be plotted. And if we put in a 0 or negative time duration, say -5, we will get a message saying that the duration must be a positive value. So now, if we go into look at the code real quick, we can see that how the error messages were generated. If the button is pushed and it generates that any of these values are outside the respective ranges, it will display an error message. Otherwise, we will create a playtime variable utilizing a linspace function, as well as the duration and sample rate edit fields. And then here we use the switch function with different cases depending on the wave type dropdown, which produces an array called ySound, which we're then able to turn into an audio player using the audio player function and the sample rate. We're able to play that function as well as plot it on the axes. And this is to create the stop button in the synthesizer. Now if we hit the save button, we will see that we also get the similar playtime and sine, square, and sawtooth wave functions here using the switch case. And then using a switch case function, we are able to save the sample to a certain sample button on the soundboard. And that is it for the soundboard and tone generator